The topic we are going to discuss today is two component systems involving the formation of compounds with the incongruent melting point. So far we have discussed the two component systems with the simple eutetic, which will form a simple eutetic system, and the two component systems which will form congruent melting point, and the third one is two component systems which will form compounds with incongruent melting point. What is meant by incongruent melting point? It's incongruent melting point. At this sharp temperature, the compound decomposes. This temperature is well below the melting point of that particular compound, and compound decomposes at this sharp temperature to give a liquid phase having a different composition and a new solid phase. So the compound is here, a compound is formed between two components, and on heating it will decompose at a definite temperature well below its hypothetical melting point to yield a liquid phase having a different composition and a new solid phase. The temperature at which this occurs is called incongruent melting point or the peritectic point. Compound C on heating gives a compound X, which is a new solid phase and the solution melt. A general phase diagram for two component condensed system involving the formation of compound AB2 is like this. Here we are plotting temperature along y-axis and composition along x-axis, and the points A and B represent the melting points of point A and B. And let us discuss the curves of this phase diagram. Along curve AC is the depression in freezing point of A on adding B to A, and here the phases in equilibrium are solid A in equilibrium with the solution, and F is equal to C minus P plus 1, that is system is monovariant along this curve according to reduced phase rule. And then the next curve is BE, which is the depression in freezing point of B on adding A to B, and the phases in equilibrium are solid B in equilibrium with the solution. System is monovariant along the curves. Then EC at point C, the new solid phase AB2 begins to separate. So EC, the phases in equilibrium are solid AB2 in equilibrium with the solution. These are three curves, and the system is monovariant along these curves. Then the area above the curves, in all phase diagrams, this area above the curves contain homogeneous liquid, and so it is only one phase, that is 2 minus 1 plus 1, that is system is bivariant. And in all areas just below the curves, one solid phase is in equilibrium with the liquid, and this is system one solid in equilibrium with the solution. So the system, on applying reduced phase rule, system is monovariant. And then the points, point C is the eutetic point, and here the phases in equilibrium are solid A in equilibrium with the solid AB2 in equilibrium with the solution. And then this is a eutetic point, and the system is invariant on applying reduced phase rule. And then the point E, which is the important point as far as this phase diagram is concerned. Point E is the peritectic point or incongruent melting point of the solid AB2, and point D represents the actual melting point of solid AB2, and point E is well below the actual melting point D. And at E, the AB2 decomposes to give the new solid phase B. So the phases in equilibrium are solid B in equilibrium with the solid AB2 in equilibrium with the solution. That is, system is invariant along this at this point on applying reduced phase rule. That's all about the discussion of system with the incongruent melting point. Thank you.